What's up, guys? Welcome to lesson 2 of chapter 12. We're going to be covering pyramids today. This is going to be our full video. Now, as I explained on Google Classroom, there's going to be a full video, there's going to be a rundown video. The rundown video is meant to be about 5 minutes, 3 minutes, really quick, just to kind of get the information out there, highlight a few points, maybe one or two tricks. This is going to be a little bit more in depth. I'll try not to ramble too much, but again, this is going to be a little bit slower, so if you need the help, you like the slower pace, this is going to be the one for you. So with that, let's get started. So dealing with pyramids, first off, when we're dealing with pyramids, it's very similar to prisms, but instead of having two bases, we're only going to have one base. One of the major differences is we are going to be having a vertex, so this is where our lateral edges meet. Basically, instead of having two bases, one up top, one down over here, we only have one, and all of them come up to meet at a singular point. So in this case, let me just adjust my pen. This right here, this is going to be your vertex, the area where they all meet. That's going to be your vertex. Now, altitudes, just like last time, altitude, or another way we can call it is height, this is going to be where all of your lateral edges meet. This is the perpendicular distance from vertex to your base. So from here to here, this perpendicular distance, this 90-degree distance here, that's going to be your height or your altitude. Lateral faces, lateral edges, you should already know what both of these are. But just in case you forgot, your lateral face, if you were to look at all of these sections that were created by each of the different parts of your base, then each of these are a lateral face. Your lateral edge is this little dividing line between the two of them over here. Now, slant height, this is going to be the height of your lateral face. I'll talk about this a little bit later on when I'm covering what your lateral face is and how you break that down. But for now, your slant height is just the height of your lateral face. Okay? Now, when we're dealing with regular pyramids, two things that you want to remember. Number one is your base is regular. Unlike last time where we said if you have a regular regular prism, it meant that it was 90 degrees, or excuse me, a right prism, that means that was 90 degrees. This one here, a regular pyramid, does imply that your pyramid's base is regular. The altitude, because of this, is going to be directly over the center of your base. So if you can find out where your altitude is, you can use the center of your base in order to figure that out. I'll talk about that a little bit more when I'm showing you how to break down the base as well. But again, your altitude is directly over. Now, also, if you notice, this is called a regular hexagonal pyramid. This is how we name it. Regular just says that it's going to be with a regular base. Hexagonal tells you the shape instead of a quadrilateral or a square or a triangle or something like that. And pyramids, obviously, pretty obvious. Now, in this class, we are mainly working with regular pyramids. We're not going to be working with non-regular pyramids too often, if ever. I'm pretty sure I'm going to just take it out from this point on, so don't worry about that. Okay, moving down, we have a couple of formulas. First formula you're going to deal with is your lateral area formula. Now again, lateral area is what is the area of all of your lateral faces, and the way we find that is your lateral area is equal to 1/2 of your perimeter times by your slant height. It's really similar to the prism one. The prism one was 1/2 perimeter times by height, but in this case, my slant height is not my height, but I'll explain why in just a little bit. But again, this P stands for perimeter. This L stands for slant height. Nice little fact on the bottom over here. It says in a regular pyramid, all lateral faces are congruent and all lateral edges are congruent. That's just a nice little fact. But basically what you're going to be doing here is you find what is your perimeter based of your base. And then after that, you need to find your slant height. Now, when you're doing your slant height, one of the most common breakdowns for me, again, I always break down my shape. I take it apart, redraw it. One of the most common breakdowns you're going to want to do is of your lateral face. Now, when you're breaking down your lateral face, this is what it's going to look like. You have your base here and here. You have your lateral edge right over here, and then finally you have your slant height. Now this area over here is your slant height. Now the reason why this is so nice is we're given a right triangle, and the reason we like right triangles is there's a lot of things we can do with them. We can do Pythagorean theorem, we can do SOHCAHTOA, we have a lot of different options. So if I said this was something like 60 degrees, you could easily figure out what this is if I told you that your base was 3. You just use your 30, 60, 90. So this is going to be over here 3 square root of 3. Now, similarly, if I told you this was 10 and I told you this was 5, you could figure out what this is by using Pythagorean theorem. So again, if you're trying to find slant height, breaking apart that lateral face, that's a really good first step to try. And again, just one more time, your formula for lateral area is going to be 1/2 perimeter times by that slant height, not your height, your slant height. Next, when we're dealing with volumes, my volume is going to be 1/3 base times height. Very similar again to the prism one, but instead of volume is going to be base times height, my volume is 1/3 base times height. So the volume of a the volume of a pyramid is also going to be 1/3 the volume of a similarly shaped prism. Now, in order to find the area of a regular polygon, you're going to use this area equals 1/2 apothem times perimeter. Now again, this over here, this is your area of your base, and in this case, we're almost always doing regular bases, regular pyramids. So because of that, we're going to be using these regular polygons. So make sure you know how to find the area of your regular polygons. And again, the area of your regular polygon is 1/2 apothem times perimeter. As a quick reminder, if this is your base, you always start at the center. You draw these shapes here. These are called your radius. And then you draw your apothem here, and then you have your triangle that you can work with. So again, if we had something like this, if this was something like 10, then we could say this was 10, which means that this splits evenly 5, 5. Now, one thing that a lot of you guys were having trouble with is you weren't sure how to find this angle over here. Now, basically, a quick way to find the angle is you just take 360 and you split it divided by the number of sides. So in this case, it's a hexagon, so there's 6 sides, which means that it's 360 divided by 6, which means it's 60. So each of these little slices of pie, I guess you could call them slices of pie, they're 60 degrees, which means that if you split that in half, that's going to be 30 degrees. And just like that, my FBI agent heard me talking about pie, so I got a notification for Domino's Pizza. Interesting. All right, moving on. So basically, that's what you're going to be doing in order to find the volume. Now, you need to find your altitude or your height in order to use this formula, so you're going to be using this right here. This triangle is your second most used take apart triangle, and it's going to be your apothem, your altitude, and your slant height. Now let me show you on this big one. Basically what you're going to do is you're going to start at the center over here, you're going to draw your apothem, and then you have your nice little triangle here. So it's slant height, apothem, and your height. Using this is a good way to find your altitude or your height. Again, it's a right triangle. You can use SOHCAHTOA, you can use Pythagorean theorem. Either of those work. There is a slightly less common one used where basically what you're doing is you're going to draw your radius, and you can draw this 90-degree angle here. So instead of using this triangle here, you can use this second one where this is altitude. This one here is your radius. And then this over here, if you notice, it's connecting right over here. So that's going to be your lateral edge. That's another one that you can use. Again, it just kind of depends on what you're given, depending on where your information is. If you're given an angle or you're given a radius right over here, then you know what? Use that triangle. Use whatever is easier for you. Our goal is to make life easy. Okay, so as a super quick rundown, basically what we know is we now know what a pyramid is. It's a one base, three-dimensional object, kind of like a prism, except there's only one base. There's a vertex, that's where all of our points meet, and most of them are going to be regular, meaning that my bases are going to be regular polygons. We have two formulas here. Number one, we know my lateral area is 1/2 perimeter times by slant height, and my volume is equal to 1/3 area of the base times by height. If we ever forget how to find area of the base, that's going to be 1/2 apothem times perimeter. There are two major triangles that we try to break down. Number one, we have our, let me move my face out of the way. Number one, we have our lateral face, and number two, we have our altitude, slant height, apothem triangle. Now the last triangle that we do have though is our altitude, lateral edge, and radius triangle. That one also works, but again, that one's a little bit less used. Okay, now that you have all of the major parts, let's go over a quick practice problem. So given the pyramid, find the total area and volume. Now if you remember total area, this is going to be equal to lateral area plus base area. So what I'm going to be doing is, in order to find the lateral area equals 1/2 of perimeter times by slant height. So we got to find this slant height. So we're going to look right over here. We have a lot of good information there. So let's break this down. So then we have this shape over here. This is going to be 8. Oops, excuse me. This is going to be 6. This is going to be L. This is going to be 6. Can't really do anything with this, so we're just going to put this on the side. Next, we have our base. Our base over here looks like this. 12, 12, 12, 12, and then finally we have this shape over here. My height, which is going to be 8 in this case, my apothem, I don't know what that is, and then finally my slant height over here. Now if you notice, we don't have enough information to solve any of our two triangles, triangle number 1 or triangle number 2. So because we can't solve any of them, we're probably going to have to mix and match some of our pieces a little bit. Now the one I'm closer to finding though is this one over here. And the reason why I'm closer to finding that one is I need to find the apothem. And it's really easy to find the apothem of a regular shape. So again, let's do that. So again, we always draw our little triangle like this. The way we find this central angle looking thing is we go 360 divided by n. So this is going to be 90 degrees. Now if I split that in half, this is going to be 45 degrees. Now that means if this is 45 degrees, this is going to be 6, this is 6, which is a 45, 45, 90 triangle, which means my apothem here, this is also very nicely 6. So because my apothem is nicely 6, we know that this is also going to be 6 here, which allows us to find our slant height, which is really, really nice. Now the way we find our slant height here is we're going to be using Pythagorean theorem. So let's set that up over here. 8 squared plus 6 squared is equal to L squared, which means that we have 64 plus 36 equals L squared, which is going to tell us 100 equals L squared, so that we know our slant height in this case is equal to 10. So because of that, we have our slant height. So in order to find our lateral area, we need 1/2 perimeter times by slant height. So we're going to get 1/2. My perimeter in this case is 12 times 4, which is 48. And then my slant height in this case that we just found, this was going to be 10, not 6. So from here, my lateral area is going to be equal to 480 divided by 2, so that's 240. Now we're not given units, so we don't need to worry about that at all. Totally fine. Now in order to find my total area though, I do need my base area. So my base area equals 1/2 apothem times perimeter. But in this case, it doesn't make sense to do this because it's a square. You know that it's a regular quadrilateral, it's a square. So it's just base times height in this case, which is just going to be 12 times 12, which is 144. So my total area in this case is going to be 240 plus 144, which is 384. Okay, that's going to be my total area of this shape. Again, we just kind of broke down all of our pieces, we looked to see what we have, and we just mixed and matched. Again, do not forget how to do your regular polygon base breakdown. That's really, really important. If you're having trouble with that, make sure you ask me, because if you're not doing good on that, you are going to be needing some help. Okay, so then now we found this, now we need to find our volume. Now if you remember, my volume equals 1/3 area of the base times by my height. So again, volume equals 1/3 area of the base. Now my area of the base is very simple. Again, it's just 12 times 12, which is 144, times by my height, and my height in this case is 8. So from here, we just put it all together. So my volume is equal to be, what is 144 divided by 3? What is that? 448 times by 8. So volume equals 48 times by 8. What is that? 320 plus 64. So volume equals 384. Hey, that worked out kind of interestingly. Now, total area and volume don't always match up. In this case, it just so happened to. It worked out really nicely like that. But generally, there's really no connection. So please don't see this and think, oh, hey, wow, they're going to be the same. Okay, so again, that's kind of how we're going to be dealing with a lot of our pyramid problems. Again, 3 triangles that you always want to break up is you always want to have your lateral face triangle, you want to have your apothem triangle or something like that, or you want to use your radius triangle. And finally, of course, you always want to make a 2-dimensional version of your base, so that way you can break things down. If you can see things, again, you don't need to. This is just a really good tip. Lastly, again, I'm just going to pull up the breakdown slide. Don't forget, you have your 2 formulas, you have your shape, and then you have your different tips that you need to break down. Okay, again, if you have any questions, feel free to reach out to me. If not, we're going to be posting this up. Again, I will be having rundown videos that are meant to be about 5 minutes or so, just cover the bare minimums, no examples, anything like that. And then you are going to have these longer videos. So depending on which ones you like, let me know. I'm willing to do both if they're both helpful. But again, just let me know if you guys need any help. Keep up with the work, and see you guys later.